Welcome. Today, we are going to take a quiet journey far beyond the reach of ordinary time into one of the most subtle and mysterious discoveries in modern science. The universe is not just expanding, it is expanding faster than we expected, and no one is entirely sure why. Imagine that for a moment. A vast cosmic ocean stretching outward in every direction, not just moving, but accelerating, as if something deep and unseen is gently pulling space itself apart, like the slowest, smoothest exhale of creation. As you listen, you don't need to hold on to every detail, just drift with the ideas, like starlight traveling through the endless dark, warm and unhurried. Let us begin. Slowly. For a long time, humanity believed the universe was still, unchanging, eternal, a grand fixed dome overhead. But in the early 20th century, something remarkable happened. Edwin Hubble, gazing through his telescope on a clear California night in 1929, began to notice that distant galaxies, those faint glowing islands of stars far beyond our Milky Way, were moving away from us. Not just a few, but almost all of them. The farther away a galaxy was, the faster it seemed to be receding. This simple observation became known as Hubble's law, and it led to a profound realization. Space itself is stretching. Not galaxies flying through space like sparks from a fire, but the fabric of space, quietly unfolding across the universe, carrying everything along with it. Imagine drawing dots on the surface of a balloon, and then slowly inflating it. Each dot moves away from the others, not because they are traveling across the surface, but because the surface itself is expanding. This is our universe, gentle, continuous, and vast beyond comprehension. For decades, scientists assumed something quite reasonable. If the universe began with a powerful expansion from the Big Bang 13.8 billion years ago, then gravity, the quiet force that pulls everything together, should gradually slow it down. Like a ball thrown upward into a calm sky, the expansion should ease, softly resisting the pull of all that matter. But then, in the late 1990s, two teams of astronomers studying the night sky with quiet persistence made a discovery that changed everything. They tracked distant exploding stars called Type 1a supernovae, which act as cosmic measuring candles, each one shining with a predictable brightness. By observing how dim these explosions appeared from Earth, they could estimate how far away they were and how fast the universe was expanding when that light began its long journey billions of years ago. And what they found was unexpected. The expansion of the universe is not slowing down. It is accelerating. Very gently, very quietly, but undeniably. As if something invisible, something woven into the structure of reality itself, is pushing space apart with a steady, unseen pressure. This mysterious influence was given a name: dark energy. A simple phrase for something profoundly unknown. We do not see it directly, we do not touch it, and yet it appears to make up about 68% of the entire universe, leaving stars, galaxies, planets, and even atoms as just a humble 5% or so. The rest is this quiet enigma, inferred through the universe's gentle drift. Now, let us drift a little deeper, at your own pace. In modern cosmology, we describe the expansion using a number called the Hubble constant. It tells us how fast galaxies recede for every few million light-years of distance. For many years, scientists measured this number in two different ways.
One method peers at the nearby universe, using pulsating Cepheid stars and those reliable Type 1a supernovae, yielding a brisk pace. The other looks much farther back, to the early universe, by studying the faint afterglow of the Big Bang, the cosmic microwave background, predicting a slightly slower pace. In theory, both methods should agree. They are simply two windows into the same cosmic story, but they do not match. This difference has become known as the Hubble tension, a quiet disagreement between the past and the present, like two old friends recounting the same tale, yet arriving at slightly different endings. Imagine drifting slowly through a vast cosmic timeline. On one side, you see the early universe, just 380,000 years after the Big Bang, a glowing sea of light and plasma, perfectly smooth, almost uniform, its tiny ripples seeding today's galaxies. On the other side, you see the modern universe, filled with galaxies, clusters, and enormous cosmic filaments, all drifting apart faster than expected. Somewhere between these two moments, something subtle may have changed. Scientists have been exploring many possibilities, each like a soft path through the stars. And right now, in early 2026, fresh discoveries are lighting the way. The Dark Energy Spectroscopic Instrument, or DESI, released its latest maps this year, charting over 15 million galaxies and quasars. They found strong hints that dark energy isn't steady. It might be changing over time, like a cosmic tide that's slowly rising, explaining why today's expansion feels quicker. The James Webb Space Telescope's 2026 data on ancient galaxies pushed the tension even higher, while Euclid's deep field images suggest gravity might bend a bit differently on super large scales, not exactly as Einstein pictured, but softer, letting expansion speed up unexpectedly. Another gentle idea from recent papers, an early dark energy burst right after the Big Bang, a fleeting push that tweaked the universe's baby steps, making far past measurements mismatch now. Or perhaps neutrinos, those whisper-thin particles everywhere, carry a touch more weight than we thought, nudging the numbers just enough. These aren't wild guesses, they're simple tweaks fitting the newest starlight clues, inviting us to rethink the universe's quiet rhythm. And recently, new observations have made this puzzle even more intriguing. JWST and Euclid are refining cosmic distances with golden precision, yet the tension holds, clearer, more insistent, pointing to new physics just beyond our grasp. Now, let us pause for a moment and simply imagine. Drift slowly through the expanding universe. You are not moving, but everything around you is gently receding. Galaxies slide away into the darkness, their light stretching, becoming softer, redder, quieter. Space itself is growing, not in bursts, but in a continuous, almost meditative expansion. No edge, no center, just an endless unfolding, like breathing in the silence of space. There is something deeply beautiful about this. The universe is not a finished story. It is still revealing itself. Even now, as you rest and allow your thoughts to drift, imagine the universe breathing, slowly expanding, softly evolving, a vast, gentle motion that has been continuing for billions of years and will continue long after we are gone. Let your mind drift with it. No need to solve the mystery tonight. Just feel the quiet beauty of it. A universe still revealing itself, still expanding, faster than we expected, and inviting us to keep wondering. Thanks for watching, and may your thoughts drift softly among the stars.